Hi folks, Matthew Lanigan here with BayWa RE. We're just going to give it another minute, see people are still logging in, so we'll be back in 1 or 2 minutes and we'll get started with our great friends at APsystems. Thanks. Hey folks, Matthew Lanigan here again with BayWa RE. Really appreciate y'all taking some time to be with us and our friends at APsystems and learn some new information in regards to their products. A couple of housekeeping things before we get going. First of all, this will be recorded. It will be on our YouTube channel. If you haven't signed up for our YouTube channel, please do. You'll find this recording and all previous recordings, so it's a great resource for all. We will be taking questions and we'll take them on the fly. If I could have somebody just test the question box to make sure it's working, that would be lovely. Okay, great. Thank you very much. Couple of things too. If you haven't signed up for our web shop yet, we would love it if you did. We put a lot of time and effort into that, taken a lot of your feedback and made a lot of changes over the last quarter or so. You can find all your specs, pricing, install manuals, inventory levels. You can do payments, create wish lists. It's a very powerful tool. So all things APsystems can be found on there. So without further ado, I'd like to introduce Chris Ling with APsystems, the Applications Engineering Manager. And BayWa and APS have been doing business now for over a decade. So really great partner and happy to have them here to learn some more about the products. Chris?
Thank you very much for the introduction, Matt. Okay, I think my screen should be sharing now, so I will be proceeding with the presentation. Yeah, so first of all, thank you very much, Matt, for the introduction. My name is Chris. I'm the Applications Engineering Manager at APsystems. And today I'll be going over just a quick overview of some new developments, both from a hardware and a software perspective at APsystems. And just as a quick overview, as Matt had mentioned, we've had a decade of experience working with BayWa, and beyond just within Canada, we have many different regions within the world. Our headquarters is actually based in Jiaxing, China, which is pretty close to Shanghai, about like a 2-hour drive. And then we have business units in Europe, US, Canada, Mexico, Brazil, Australia, and obviously Canada's our favorite, right? We started our company in 2010, and we've had a pretty long history in terms of our product development and where we started doing business. And we actually just hit our 15th year anniversary earlier this year, around, I think during springtime. So just wanted to mention that this would not have been possible without the cooperation support from BayWa of being able to bring us to the market in Canada, but also just the customers, the US customers as well, has been a huge part of our success. So first of all, I do want to extend the appreciation and gratitude that we have for working with you all. So thank you very much. So for today, I have a couple of topics that I'll be going over. First topic is going to be pretty boring. It's going to be going over an overall architecture and review of our microinverter platform. I'll talk next a little bit about our new hardware, which includes the APsystems Combiner Box, QS2, and our AP storage product line. I'll go over some new ECU features, some new EMA features, and I'll talk a little bit about our new training program that we recently released. So yeah, definitely a lot of interesting topics. I will probably go pretty lightly on each one, but hopefully it'll be interesting for you all, and hopefully you will learn something for today. I'll start out with like very basic information. So for us, our bread and butter is our microinverter product. In the residential space, our DS3 is our residential microinverter. And it is paired with the ECU, which is the gateway device that gets data from the microinverters, which then uploads the data to the internet, which is and the data is accessible through our EMA online monitoring platform. And then our residential solution is very similar to our commercial solution. So this is the QT2 microinverter. It's 4 panels into one. The nice thing about this product is that instead of putting, it's really great for 3-phase systems. If you don't have to do like get single phase inverters, put them onto each branch, and then do phase balancing on all 3 branches. So none that is necessary for the QT2. All it does is it natively outputs 3-phase without having to do any balancing that you have to set up. It's all done natively with the QT2s. And same platform uses the ECU to collect data from the microinverters and it uploads the data into the EMA platform. So very similar. In general, obviously I'm biased because I'm from APsystems and we work at a microinverter company. Microinverters are generally really good for certain particular cases. If you're doing like a really large system with a large number of arrays, I generally don't recommend microinverters because the BOM costs can get quite high because you have to have a lot of MLPs per as your size increases. But if there's a scenario where the nice thing about microinverters is because you're not stringing panels together, the only voltage that you get is basically low voltage DC. Actually, this is in this case, this actually I had the wrong image over here. It's not below 120, it's actually below 60 volts. Because the largest DC voltage that you will get on the roof is a single panel, which is going to be your open circuit voltage of a panel. Whereas unlike a string inverter where you're putting the panels in series together, you're gonna have voltages that are gonna be pretty high. So this matters because if you have high voltage DC on a system, there is definitely a risk of high voltage arcing. So that's just one thing to just be cautious of when you're doing these types of systems. If you're working at a location where like high voltage DC arcing is something that you want to avoid at all costs, a microinverter solution will be able to get rid of that, so you don't have to worry about that risk. Another thing also to note as well is failure impact. So for microinverters, if a microinverter goes down, since it's all AC coupled, the other microinverters will still continue to function. Whereas if you have a string inverter, if that goes down, then the entire string or the entire array goes down because it takes down the entire string. So once again, this is really useful in terms of being able to mitigate issues. Another also very important thing is that you get module level monitoring as well that you don't necessarily get from a string inverter. So if you have a customer where that is very important, or if you want to have that visibility from a debugging perspective, this will also give you that power to be able to see where are issues, or just in general, like where the shading is, where are your most performant areas, and things like that. Okay. All right. So that's just basically a quick overview of microinverters. I hope that everyone this is old news for everyone. So now I'm going to go into some more interesting and spicier topics. Basically on a new hardware that we're coming out. As mentioned before, as Matt had mentioned earlier, if you have any questions about anything, please don't hesitate to ask. I enjoy the dialogue and enjoy thinking on the fly, so I'm more than happy to answer any questions. But before I move into new hardware, any questions about anything I had just discussed about microinverter architecture?
Not seeing anything at the moment. Thank you.
Cool. Sounds good. Yep. Yeah, that was, I think a lot of that is old news, so should be pretty straightforward. All right, so let's talk about new hardware. This is not new hardware, but I do want to talk a little bit about a thing that we've sort of been noticing among our customers. So as mentioned earlier, the ECU is our gateway system that is responsible for collecting data from the microinverters and sending it to the internet. We've had a lot of customers who will want to have CT integrations with the microinverter solution, whether that's in the form of export control or consumption monitoring. So the ECU-R does not have a way where you can plug CTs into them, but then the ECU-C does. And as you can see from the unit down below, there are some terminals that you can stick CTs into to be able to measure currents that are outside, are not related to the microinverters. And you can use that to measure production and consumption and export and do export control as well. A common thing that we've noticed that a lot of customers are really interested in is doing consumption monitoring, where you use the ECU-C to measure CTs. And one thing to note is that this is definitely a use case for the ECU-C to get consumption monitoring in the APsystems cloud. So the way that we generally recommend doing this is this is where the CTs are. The production CTs go in here. The grid CT, so this is where you're going to measure the import-export power of the site. And typically you would put it in between the main service panel and the home service panel and the utility meter. So you get power import and export, and that way you can also get consumption metering as well. One thing I also want to note is what's also important is to make sure that you have not only to power the ECU-C, you need L1 and neutral to have voltage across it. But if you want to measure power on both phases, power is a function of current and voltage, right? So if you're measuring currents, that's going to be from the external CTs. But if you also want to measure voltage, that's where this plug comes into play as well. So just remember that when you're doing split phase consumption monitoring and you want to measure both phase consumption, make sure to plug in L1 and L2 to be able to get voltage readings from the ECU-C. So this is not new product, but this is a common solution to get split phase consumption monitoring. But what is new product? Oh, actually no. This is basically some graphs that you can get once you get those readings. So what is new product is the AC Combiner Box. So the purpose of the AC Combiner Box is that it's supposed to streamline metering, AC wiring, and communication. What it physically looks like is it's a box, like on the left side. It's a thing where you can put breakers into. There's an there's ECU-R inside of the box. There's also an external meter that you can plug CTs into in this box as well. And it basically allows you to have a more streamlined location where you can put all your strings into. So what that looks like from a electrical standpoint is you have a combiner box right over here. You have your microinverters land inside of this AC combiner box in here. And then power comes from the AC combiner box going to your main load center. And then from the CT perspective, you're going to be putting, so there's internal CTs right over here. That will basically go where the solar strings are going into. And then you're going to be taking external grid CTs that go between the main panel and your meter so that you can measure the import and export power from your system. And yeah, this is what it actually looks like in real life. So as mentioned earlier, this is where all your solar goes into, and then your strings basically go through the CTs down below. And then this is the meter itself that allows you to stuff CTs into. So it allows you to do both consumption and production metering. As mentioned earlier, there's an ECU inside of this box. And actually, this is not a standard ECU-R. This is actually an ECU-R 4G. This ECU-R allows you to do Ethernet and cellular communication. So there's a slot that you can put inside a SIM card to allow you to do cellular communication. One note is that this ECU does not have Wi-Fi communication. We are having a conversation internally whether we want to have these combiner boxes to also have Wi-Fi capability as well. Our initial thinking is that if this is a box that's going to be outside, you may not have good Wi-Fi connection, so it's not necessary to have Wi-Fi. But we're starting to realize that it might actually be needed just as an option And then if it's not, and the Wi-Fi cannot reach that area, then you would use Ethernet or cellular communication. One other note also is that we don't provide the SIM cards offhand. This is another thing that we're also working on finding a better solution for as well. In general, I recommend getting SIM cards that are M2M. So not like the same ones that you use for cell phones, but ones that are primarily used for IoT or machine-to-machine type applications. There's one company that I personally like to use. It's called One NCE. So One Nancy Charlie Echo. I think that's native speak. So that company, they sell pre-activated SIM cards. I think I want to say they sell it like $15 for 500 megabytes or something along those lines. And then when you run out of data, they also auto top off as well. So I personally like using those SIM cards with these systems. There's a maximum of 110 amps for solar, so you can do 520 amp breakers, or what is that? 330 amp breakers on here. It's IP65 rated, so it can be outside, and it's also UL 1741 rated as well. So once again, this AC Combiner Box is useful if you want to do if you want to have a better integration to do CT measurements, and you want to have cellular communication with this system. We do not require every site to have an AC combiner. But if you want to, but it is optional and you can potentially get some good labor savings just by using this AC combiner box. Okay, I'll pause over here. Any questions regarding this AC combiner box that we're discussing here?
Any questions, folks?
If not, I'll move on, and then I'm happy to come back as well.
Yeah, we have one from Kyle. Are these CSA approved now?
Yes, they are. We have the certificate uploaded on a website. I will, if you need if you're having difficulty finding the certification document, I can email it to, well, I guess maybe email me and I can email it to you guys, or maybe we can put.
Yeah, they can just reach out to their sales rep. And what is the stock availability locally? I don't believe we have stock on these currently, Kyle, but if you just want to check with your account manager and this is something you'd like us to stock, we can definitely work towards that.
Great. Yeah, thanks, Matt.
Okay, I think we're good for now.
Great, sounds good. Yeah, more than happy to answer again if you come up with other questions. All right, next product that we're talking about a little bit about. So familiar with the DS3s, which is dual module single microinverter. A lot in the past, we've had some customers had interest in their what we call the QS1, which was our 4-to-1 microinverter. And just to be blunt, some people like it, some people didn't. The one biggest complaint is the DC extension wiring, because when you have 4 modules into a microinverter, it's definitely you definitely need to be, how to say, strategic with regards to DC extensions. But if you're able to figure that out, you can get some major cost savings because you have fewer microinverters, right? So we're starting to do soft launches of the QS2, and the power output of these are 1920 watts. So this actually allows you to put 3 on 30 amp breaker and 2 on 20 amp breaker. So 3 times 4, that's 12 modules, and then 2 times 4, that's 8 modules on 20 amp. Right now, the AC output of these are 480 watts AC per channel. So what this means is you can probably recommend like 500 watt panels or above for these microinverters. And these microinverters are also, these QS2s are also Zigbee communicating as well. So if you have a site that already has DS3s and already already has an ECU-R or C, this will be able to communicate with our existing platform. If you have the YC500s that uses our old PLC method, that you'll need to get a separate ECU for those. But our more current line, it will be okay. So in any case, I think these are not normally stocking as we speak right now. But we are planning on releasing them pretty soon. I guess I want to say Q1 is my estimate. But yeah, I think this is also a similar situation with the AC Combiner Box, where if you're interested, definitely talk to the sales rep, and then we'll have someone follow up with them afterwards as well. All right, any questions regarding the QS2s?
I'm not seeing any at the moment.
Cool. All right. Next part I'll talk a little bit about is going to be 11.4K. This is our residential home battery storage inverter. The nomenclature we came up with is E is energy storage system, L is low voltage battery, S is split phase, and it refers to 11.4 kilowatts of output power. The way I like to describe this is, I hate making this comparison, but I'm going to do it anyways. It almost looks like a hybrid inverter, where you DC couple it with a battery. But it's not a hybrid inverter because instead of connecting, because it does not have MPPTs for solar, and you don't connect DC solar into the system, because we want our battery system to work with our microinverters. So in fact, it's actually AC coupled with solar. So with solar, it's AC coupled, and with batteries, it's DC coupled. BayWa carries Soluna batteries, and those actually work quite well with our ELS 11.4K. I like to think of it as a battery inverter, so very much like how a microinverter makes a DC solar panel be able to interface with an AC grid. This ELS battery inverter makes a DC battery interfaceable with an AC grid. So it's bidirectional. You can charge and discharge to the batteries. It outputs 120, 240 volt split phase on its own. 11.4 kilovolt amps if it's if we're talking pure power, but then if it's perfect power quality, then it'll be kilowatts. And then it's possible to have solar when you have a grid outage, and it does this by AC coupling with solar. It's possible to use this for both backup uses and for self-consumption purposes if you don't want to use the grid and save energy, save electricity. And the time for it to switch to its backup loads is also very quick as well. This is sort of how the most common diagram of how the system sort of works. Let me see, oh, laser pointer, great. So this is where your main panel sits. You have a backup load center over here, and then you have your battery inverter over here. This is where the battery goes. And then you'll be able to charge from the grid to charge the batteries, or use the batteries to export power, or use the battery to power the loads in your home instead of buying power from the grid. This is where your solar gets connected into as well. So, and then as mentioned earlier, if you have a power outage, this goes out, so the loads in your main panel go away. But then the battery inverter will have 240 on backup, 240, 120 on backup, and will also apply 240 onto the solar inverters to keep it on as well. And then you have an app that goes with the battery system, and then it also connects, communicates to the internet for both remote monitoring and any sort of a remote control can be done as well. Okay, so that's the battery system, and here's some examples installations that we've done with Soluna. So as you can see, this is our battery inverter, ELS 11.4. This is actually our older generation, the ELS 5K. But then, and this is one of Soluna's older batteries. And then here's like some other like examples of us working with Soluna. So yeah, we've done a lot of installs with Soluna. So we're excited to bring that and work together with Soluna and be able to bring this to Canada. Okay, so I'll pause here. Are there any questions regarding the new hardware that we discussed? Now, the next thing I'll be talking a little bit about is the ECU related features, but yeah, AC Combiner Box, QS2, 11.4K. Any questions regarding those?
Daxis, just wondering when this will be available for purchase. I think that's in regards to the ELS, I'm guessing, but those are currently available and we are selling. that's it for now.
Cool. All right. Thank you very much. This slide, I think I added a little too early, so I apologize for that. So next thing I'll be going over are new ECU features. So this is sort of part of the continuous improvement process that we wanted to improve with our system. So I'll talk about two new features with our ECU gateway device. So first of all, we have a new feature called automatic data refresh. You might have already seen this, but on the top corner of the module view, there's a little like circular like refresh type button type thing, and if you press it, what will happen is so normally the ECU collects data from the microinverters every 5 minutes. So one thing that can be a little bit frustrating is that once you do some changes on the microinverters, you have to wait an additional 5 minutes for them to see anything happening. So one thing that we have added is an automatic data refresh feature where it's going to be pinging a lot more often. I think I want to say every 30 seconds is when it pulls data, so that when you make changes in the field, you'll be able to see those changes a lot faster. So once you say okay, then what will happen is that data will start recycling a lot faster, and then it will automatically disable itself after an hour once you're done using that mode for debug. Note that this feature is so according to NEC, the microinverters will only produce power after it sees AC voltage after 5 minutes. So it does not override that. It just simply overrides the polling. So what you might sometimes find is that when you turn on AC, you won't see power coming through the microinverters until 5 minutes afterwards. And it still happens because of NEC code. So just be wary that that is still in play and does not override that. All it does is just increase the polling frequency of the data of these microinverters. Note that this is also only doable through local access mode. There was a feature request for us to have this in the cloud. We are still looking into doing that, but this is primarily only just for on the field when you're doing local access mode. Okay. That's the first feature of the ECU. And then the second feature of the ECU I want to talk a little bit about
we've
is
got a question here from Dave. Would ELS 11.4 kilowatt inverter work with non-APS microinverter system in mode?
Yeah, good question. So the quick answer is yes. The reason is that if you think about from a inverter perspective, a inverter is only going to be pushing power if it sees 240 on the AC side, right? And then there's also an additional nuance of when you go off grid, how do you turn off the solar in order to prevent overcharging of the battery? So what we do is that we basically turn off 240 if the battery gets close to full to turn off the solar. And then when the battery is sort of depleted and is ready to accept more power, then it will turn on 240 on this line again to turn on the inverters to start pushing power back to the battery. The one other thing to mention as well is that there is a maximum power that you can put on this port over here. So the quick answer is that you can use other brand inverters, but they just need to be under a certain power limit. I unfortunately won't be able to go over that during this training, but there's actually a way that you can get more information on that, which I can touch upon at the end of this seminar. Yeah, thank you for the question, by the way. Any other questions?
That appears to be it for now. Thank you.
Great, cool. Great, thank you very much. Cool. All right. So the second ECU feature I want to talk a little bit about is using the app to update the ECU firmware from the EMA. You might have seen this window where you see like new software download reminder. This is basically the ECU that's on the firmware on the ECU. So once you do this procedure, it's just basically downloading the firmware package onto your phone. And then once you say it's good, it's downloading, what will happen is that whenever you do a local access connection to an ECU, it might ask you to say like, oh, I noticed that your version of the ECU is lower. Do you want to do an update through the phone? And then you can say okay, and then what will happen is that your phone will then send the new firmware package onto the ECU. And then you say okay, and then you say okay, and then when it's done, you say okay, and it'll be updating to the newest firmware. This is so note that you actually your phone does not need to be connected to the internet during this time in order to perform this update, because the firmware is already on the phone, right? So you just need to have a local access to the ECU to be able to just load firmware from your phone into the ECU, and then that will be sufficient to get your updated data. All right. Cool. So those are our two new features regarding our ECUs to basically make it a little bit easier to do your commissioning and your installation on site. Any particular questions regarding ECU updates? If not, the next thing I'll be talking a little bit about is the new features on EMA.
I think we're good for now. Thank you.
Okay, cool. Thank you very much, Matt. Great. So so there's two new features I want to go over on the EMA online monitoring platform. The first one is our intelligent diagnosis debugging tool. And the purpose of this tool is to make it, how to say, easier for our customers to do some of their own diagnosis on the systems, just to see what what could be the potential issue and what could be potential things that we can look at. So it could be, if you go to the side of the EMA website for the customer, if you go to Intelligent Diagnosis, that will be the page that will let you know the different things about the site. I will talk about two classes of issues. The first one is the ECU communication issue. So the most common issue that we usually see with ECUs, well, I would say that's pretty straightforward, is basically, is it connected to the internet or not? And usually the easiest way to tell is that if you go to Intelligent Diagnosis and you see ECU network connection issues detected, you can go ahead and click on the action, and then it will tell you the last, basically heartbeat, the last time it has sent a report from the ECU. And then yeah, so if you find that this time or date is like really old, this means that usually the ECU is either not communicating to the internet anymore, and it could be either because the ECU sometimes it's a end user issue, where sometimes the Wi-Fi network got changed, the ECU got powered off or got unplugged. Sometimes it's possible that there's something wrong with the ECU where it just kind of went kaput and is no longer working anymore. So both of those are potential reasons for why you would have a very late heartbeat. And you can also look on the ECU itself to see if it is if the lights are on and if it's connected to the network. And then that way you'll be able to see how to say, as a first line of diagnosis is to see if the ECU is indeed communicating or having issues. There's also a distinction between so the status can be either gray or red. The red status means that it has communicated in the past, whereas the gray where it has never connected in the past. So you can also use that to distinguish between those types of issues. So red ones is usually it worked in the past and something happened that caused it to stop reporting, whereas gray is basically it has never reported at all. So in any case, so that's basically the one class of issues that you can use intelligent diagnosis to confirm what the nature of the ECU communication issue. I would say these are pretty straightforward. The one I would say is more interesting is going to be the microinverter checks, because for microinverters a lot can go wrong. So one class of issues is if the inverter is off grid. What basically means is that it sees DC voltage and is able to communicate with the microinverters. But then if you notice in this example over here, AC voltage is currently 0 right now. So in this case, in this example over here, you can see that that because there's no AC on this microinverter, it could mean a couple of things. One, it could be that the unit, if it's just a single unit that's dispersed, it might be a unit, it might be a microinverter to bus cable that might be having issues. But if you notice that if there's a bunch of microinverters in the same branch, that does not seem to be having the inverter off grid issue, or there's like no voltage, or there's no voltage on the AC side, then it could be something wrong with the AC bus cable, or maybe someone just flipped the disconnect, or maybe like a breaker had tripped or something along those lines, and then that would have impacted the entire branch as well. This is also another good reason why in our array map, when you're putting the locations of the microinverters onto the module view, putting them where they actually are, or putting them on like which microinverters are in which branch, can also be very helpful as well to distinguish between when random units going off versus random units all in the same branch that are having issues. Another class of issues is low power, where it's basically have the where the microinverters basically are having the currents are very low, and you find that the power that's being outputted by the microinverters are low. So for those, a couple things to check is basically if the panels are indeed connected to the modules. In this case over here, we can see that the modules are indeed connected. Because we see 42 volts. Actually, another note is that if you have a panel that is disconnected, we typically see voltages of like 12 or 9 or something along those lines. That's like this floating voltage of an unconnected module. Actually, one other thing I also want to point out as well is that we've actually seen some modules. This is a little bit of a non sequitur, but I think it's kind of interesting. We've seen some cases where a module, the voltage drops like by a third. So if the module is normally operating at like 35 volts or something along those lines, and then we see the voltage drop from 35 to 20 something, so about a third. We notice that sometimes happens because like the module has like a diode problem that basically takes out 1/3 of its cell. And we can actually typically see that when the voltage drops by like a third, and that usually indicates a module problem. One other note also is that we see sometimes when these modules, when you disconnect them, the voltage jumps back up to the normal voltage, like 35 or 40 or something along those lines. But then when you reconnect them to the microinverter, it drops to 2/3 again. This phenomenon happens. This phenomenon happens because if the diode goes bad, then you only see the problem when the module is under load or when you're trying to produce power onto it. So in any case, that's something that we've noticed in the field, where you see like the voltage drops by like a third. That usually indicates a diode problem on the module. It's very rare this happens, but it happens sometimes. So that's like a one side note that we've sometimes seen in the field. Another issue that we've also seen is the inverter is not communicating. And you can very easily see that on the module view where it says NC. But then if you look at the module or look at the inverter itself, you see like no data. So for those types of scenarios, it can either be one, the microinverters are not close to the ECU. Two, there is something that's causing interference between the microinverters and the ECU. Or three, that there's something actually wrong, or actually three, that the microinverters do not have any panels on them. One note also is that a microinverter is only powered if it has DC voltage. If you have AC voltage only on the microinverter, you won't be able to get any communication because it's only purely powered off of the panels or the DC voltage. Another option is that it could possibly that the inverter actually has problems. So one thing you can immediately tell is that if you go on site and you see that a microinverter, there's no flashing LEDs on the microinverter itself, then it means that it's not on or it's not on and does not have any power, so it's not able to communicate with ECUs. So if you see those NC types of issues, those are the different options that we typically see. Is either a bad communication interference, or the microinverter is not powered, or the microinverter indeed has some sort of issue where it's not able to power or communicate with the ECU. We've also seen issues where it's like if you see that where we've seen like the voltage of the module goes very low to like 3 volts, and you see like a really high current. It almost looks like a short circuit type of a view. So what we typically say is that if the module has worked normally before, where you see like a voltage that's like that looks like VMP, and then suddenly goes from VMP to like a low voltage like this, then we usually typically think that it's a faulty inverter. So we ask that you give our tech support a call so we can just do another final check at it, and then we can and then we would issue RMA if it is indeed a problem. But if it has always reported in this sort of a fashion, then we've also sometimes see is a result of either the terminals of the modules were reversed, or you did like a cross connection of the modules where you have one whip from one module connected to another whip of another module on the same channel. And that could also sometimes cause this sort of like a short circuit issue before. So just to summarize, if it's always functioned like this, it's possible that the terminals were swapped or cross connected. But it has worked normally before, definitely give us a call, and then we can evaluate to see if this needs a replacement. And then we also sometimes see we have over voltage on the AC side. So it looks something like this, where you see, so this example over here, the voltage is 266, which is a little bit high for our 240 grid. So in this type of scenario, there's 2 solutions. The first solution is you can give our tech support a call to expand what we call the AC parameters of the microinverter. So with any inverter technology, it's only going to be pushing power if the 240 voltage on the AC side is stable. And if it goes over certain limits, then it will shut itself off, basically thinking that, oh, it's an unstable grid and needs to stop pushing power. One thing we can do on our background is that we can expand those limits to be a little bit higher. So expanding the AC parameters of the microinverter to allow power to be pushed through those limits. But oftentimes those limits can be like so high, and that's usually as a result of the second option, which is to have thicker wire, because the voltage. This is basically the voltage rise effect. If you find that when the solar is producing power and pushing power, and then the voltage increases quite significantly, usually just means that that you may need to have a thicker wire between the trunk cable going down to the AC combiner. So just to sort of go step by step, when you have thicker wire, the wire has lower resistance, and when you have lower resistance, the voltage that increases when you go from point A to point B is smaller, because I times R is equal to voltage rise. So when you have a smaller R and the same I, V also gets smaller as well. So so that's why voltage rise calculations are also important as well, and to make sure that the right wire thickness is being used to accommodate the voltage rise effect. So just to summarize, if we do see high AC voltage, give our tech support a call and we can increase the AC parameters of the inverters. But if it's not possible and those AC voltages go way too high, then the other way is basically to have thicker AC cable to have less voltage rise. All right, so that's the individual inverter alarms. And then one other thing I also want to mention as well is that one other tip I also want to mention is that if you have a list of all your sites, you often can see the system status for each of the projects. And that also just gives you a good idea of like the general overview of the status. Green is like the system is functioning normally. Yellow means that some of the microinverters have some sort of alarms. Note that if it is a cloudy day, it is possible that a system is going to be yellow because it's going to be considered a low power voltage, low power alarm. So if we have yellow, it may not necessarily be the worst. Red means the ECU is no longer communicating to the network, and gray means that there is no data that has ever been uploaded from this ECU at all. So usually you'll see gray when you just created a project and you just started, and then hopefully it turns yellow and green as your project makes progress and the ECU is connected to the network. Okay, so that was a lot. I'll pause here. Any particular questions regarding the intelligent diagnosis of on the EMA and just general debugging techniques on microinverters?
Don't see anything currently. Any questions, folks, while we have EPS with us?
Okay, if not, I'll just move on to the next topic. But yeah, feel free to listen to other questions as well.
Yep, we're good.
All right, cool. So the next tool I also want to bring up as well is called the EMA AP Designer. If you look on top of your EMA account, you might see AP Designer on the top, and you're probably wondering what the heck it is. So the AP Designer is basically a tool that we sort of released to make it easier for you to do designs using our products. So the first step is basically you have a project. You either go into Google Maps and put a address, or you can upload a PDF of your plan set. You lay down your modules, lay down your microinverters and DC AC wiring connections. This can be done either automatically or manually. We have an AI feature that allows us to just quickly map everything correctly together. If I'm being blunt with you, it works decently. Sometimes it's good as a first pass, but sometimes you have to delete certain sections and fix it up. And then once you create your design, you're also able to put together a BOM based off of the layout that you create. So it will take into account and calculate the AC caps you'll need, DC extension you need for your system, how much trunk cable, how much microinverters, and so on and so forth for the design. So yeah, this tool is already live on the EMA website, and you're free to use that to just make designs on the EMA. I think that's all I have for this topic over here. Cool. All right. If there's nothing else, my next topic is going to be about our new training resources and training platform. But any questions regarding the EMA about either the intelligent diagnosis debugging tool or the AP Designer tool?
Doesn't look like there is any right now.
All right, cool. All right, so the final topic I'll be going over is basically general training resources. We recently released something called APsystems Academy, and this is something that you can self-enroll. And the URL is basically academy.apsystems.com. You can create an account, and this is all for free. Yeah, this is all for free. So go ahead and create an account, and then you will be able to go in to take some trainings. We currently have 2 trainings live right now. We have one on the ECU EMA training, where it basically goes over how to commission, how to set up ECUs, how to create accounts on the EMA. And then our second one is actually our 11.4K installer training. There was an earlier question about can you use any other solar on the ELS product? And then I had mentioned in the comment that there's actually a limit in terms of power that you have to think about as well. All of those details are gone over in our self-paced installer training in here. And it's basically self-paced short form videos that you can just go through. And then at the end of each section, there's quizzes that you can use for self-assessment. And then we have a final exam. I hope this doesn't bring or trigger people from their license exams, I guess. But at the very end, you get a certificate of completion that basically indicates that you have completed training. As of right now, we're not requiring this for installers to do. But we highly recommend, especially for the 11.4K, where there's a lot of nuanced information on how to install and commission the system. I highly recommend taking the training just it's just to prepare yourself for the install, so you know what to expect and what to do. It also goes over how to do design as well. So it talks a little bit about like breaker sizes, string sizes, what you can do on the system. So
Chris, we do have a question from
yes.
Kyle. Any plans to include the ability to track warranty claims and check the microinverter communication strength via the EMA?
Oh, yeah, good question. So with regards to keeping track of communication strength, we have made that request internally for quite a while, and they are in the middle of developing that feature for on the EMA. So I'm a little embarrassed to say that I actually don't know the estimated completion time of that feature, but it is something that we're working on.
Thank you.
Yep. Yeah, thank you for your questions, Colin. Yeah, so in any case, so APsystems Academy is a new platform that we're using to go over training, and we're hoping to release more as we get more and more topics, as we get more and more products as well. Second thing also is that if you haven't already, make sure that you have an EMA account. We typically make EMA accounts for companies / customers, and so from there, that's I think if you're already an existing customer, this is obviously not necessary. But then if you're looking to join the APsystems family, definitely make sure to have one registered for your company. All the commissioning is an account is not necessary when you're doing local access mode commissioning. But it is just necessary if you're creating accounts for your end users. Okay, I think, oh yeah, this is also our technical support number, 8 a.m. EST to 5 p.m. PST. We have a dedicated technical support line, and yeah, we also not only do we have technical support dedicated for our Canadian customers, we also have a dedicated line for storage as well. So just make sure to listen to the phone tree. One is for Canada, one is for storage, and then you'll be directed to the correct parties once you make those. Once you make that selection, if you mess up, well, it's okay. We can direct you to the right queue. Okay, that is all I have to present. So yeah, definitely like a huge amount of information during this time. But hopefully it gives you a good idea that from our side, APsystems, we're committed to making improvements on our products and committed to making improvements on our processes as well. I will stop and pause. Are there any questions that you guys might have? I can also wait a little bit longer if there's any questions that might be burning. So.
Don't see any at the moment. How far away are we from your quad micro from being reintroduced? So people have been asking about that.
Yeah, so we have samples. So we have I think we started selling them in certain regions already. I would give I'm actually not sure if we're ready to sell QS2s. I know the QS2s, they are certified in Canada, so they all have like the smart grid related certifications and everything like that. I don't know if we're doing like early samples or if we're doing actual sales quite yet. But I know that we do have numerous installs of the QS2s in the world right now though.
Okay, wonderful. Yeah, and thank you, Chris. Really appreciate. Oh, here we go. When can we see improved mapping ability for sites? We need to be able to freely rotate modules. 90-degree rotations are no longer sufficient for residential applications.
Oh, are you so you need more than just 90 degrees, so like 45-degree rotations or something more granular than that? Is that the request?
Yes.
I see. Okay. Okay, I will make a note of that. Yeah, I'll make a note of that. But thank you for sharing that. I had noticed that for some instances where that more granular rotation is necessary. So I'll make a note of that.
Great. And thank you everybody for attending. Thank you, Chris. Thank you, APS. Been a tremendous partner. Like I said, been over a decade now. So really proud of that relationship. And just a couple of things before we go. Once again, this was recorded. This will be on our new YouTube channel. It'll also come out in the next newsletter. If you haven't signed up for the web shop, please do. You can go in there. You can find all the specs, the pricing, inventory, such. There will be a few APS items coming out on our Black Friday sale, which is going to be released almost any time now. So there's a couple of items on there that are well priced. As always, if you have questions, we have a really great sales team. Please reach out to inside or outside sales. They'd be happy to help you. And thank you, everybody, and have a great rest of your Wednesday. Thanks, everybody.
Thank you, everyone.